Hello friends, I am Dr. R.S. Jagdish, Professor of Chemistry, Department of Chemistry, JSS Academy of Technical Education. Today we will discuss about corrosion. What are the causes for the corrosion, types of corrosion, and factors which influence corrosion. First of all, what is corrosion? Corrosion is the process of gradual deterioration or decaying or disintegration of a metal from its surface due to unwanted chemical or electrochemical interaction of metal with its environment. In simple terms, one can say corrosion is the deterioration of a substance due to its reaction with environment. For example, rusting of iron, most familiar one, formation of black coating layer on the surface of silver. Metal loses its luster, that is, it loses its shining, that is mainly due to corrosion. Green coating on copper metal. These are all the examples for corrosion. The main causes for corrosion. Main causes for corrosion. What is the main cause for the corrosion? Metal exists in nature in the form of oxides, sulfates, carbonates. These chemically combined state of metal, known as ore, has low energy and is thermodynamically stable. Metals are extracted from these ores after expending a lot of energy. The extracted metal has high energy and thus it is thermodynamically unstable. Thus, it is a natural tendency of metal to go back to thermodynamically stable state. For that reason, the metals interact chemically or electrochemically with their environment to form a layer on the surface of compound and thus undergoes corrosion. Say, in simple mechanism, we can say that you have a ore of a metal which is thermodynamically stable. It will undergo metallurgical operations with a lot of energy. You will going to get pure metal, which is thermodynamically unstable and which in turn reacts with environment to get corroded metal. Right? Let us discuss what are the important theories behind the corrosion. The first theory is acid theory of corrosion. This theory suggests that corrosion of metal is due to the presence of acids in surroundings. So in surroundings, that is nothing but the environment. We have carbon dioxide, moisture, oxygen. So here carbon dioxide reacts with the moisture to get carbonic acid, right? So for that reason, this theory says that corrosion of metal is mainly due to the presence of acids in surroundings. This theory supported by the analysis of rust that gives the test for carbonate ions, because here the corrosion products are the mixtures of FeH, HCO3 twice, FeOH CO3 and FeOH thrice. So further the rusting of further the process of rusting reduced by the presence of lime and caustic soda, because lime and caustic soda absorbs carbon dioxide, thereby there will be a reduction in corrosion. So these are the reactions. This is about the acid theory. The next one is dry or chemical theory of corrosion. According to this theory, certain gases in the atmosphere directly attack the metal surface and form a layer of corrosion product that further resists the corrosion of metal. For example, corrosion of tin metal in chlorine atmosphere results in the formation of volatile essential food. Another example is alkali metals are highly reactive in atmosphere. Alkali metals are attacked by atmospheric oxygen and finally it will be converted into metal oxides. Silver, gold, and platinum also forms oxide films at higher temperature. So here both acid theory and the chemical or dry theory, see, they explain how the corrosion takes place, but this is not accepted thoroughly by the scientific world. The most accepted 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 theory is wet or electrochemical theory of corrosion. According to this theory, there is a formation of galvanic cell on the surface of metals. Due to this, there will be a formation of anodic and cathodic region on the surface of the metal, which can be explained as number one, due to non-uniform or rough surface of metal. Number two, presence of impurities in the bulk of metal. Number three, due to difference in concentration along the surface of metal. So, according to this theory, there is a formation of galvanic cell on the surface of metal. Some part of the metal surface acts as anode and rest acts as cathode. The chemicals in the environment, that is oxygen, carbon dioxide, humidity, acts as electrolyte. At anode, oxidation takes place, while at cathode, reduction takes place. Corrosion product is somewhere between anodic and cathodic areas. Let us take an example, that is rusting of iron. What is rust? Chemically, rust is hydrated form of ferric oxide. Rusting of iron generally caused by moisture, air, carbon dioxide, and oxygen. It has been observed that rusting of iron takes place only when iron is in contact with moisture. So it is believed that non-uniform surface metal or impurities present in iron behaves like a small electric or galvanic cell. In this small galvanic cell, pure iron acts as anode and the impurities acts as cathode, and the chemicals which are present in the environment, that is air, water, carbon dioxide, oxygen, humidity, acts as electrolyte. Let us see how the reactions takes place, corrosion reactions takes place at anode and cathode. Let us take at anode. Anode is a pure metal which undergoes oxidation and loses electrons to the environment and pass into the solution in the form of positive ions. Say for example, let us say M is a metal that is in the solid form. It undergoes oxidation, loses electrons. You will going to get Mn plus and n number of electrons. Suppose if iron is the example, iron undergoes oxidation, loses electrons, and you will get Fe2 plus and 2 electrons. Right? These free electrons released at anode are carried to cathode through the metal surface and are responsible for the following reactions at cathode. So here two types of corrosion takes place. The number one is hydrogen evolution or hydrogen type corrosion. This hydrogen evolution or hydrogen type corrosion corrosion takes place in the absence of oxygen and in the presence of acidic atmosphere only. That means in acidic solution, in the absence of oxygen, the common reaction is the reduction of H plus ions to H2 gas. So where you will get the H plus ions? H plus ions are produced due to the ionization of H2O. So H2O undergoes ionization to give 2H plus and O2 minus. The electrons which are released at anode reacts with H plus ions to give H2 gas. So overall reaction is Fe undergoes oxidation to give Fe2 plus and 2 electron, and 2H plus that reacts with the electron to give H2 gas. Overall reaction is Fe plus 2H plus that gives Fe2 plus and H2. So here what is happening? Hydrogen is evolving. So a anode oxidation takes place. It loses electrons. These electrons are moved through metallic surface to the towards cathode. There it reacts with H plus ions. These H plus ions are produced due to the ionization of H2O, and these H plus ions that reacts with the electrons to give hydrogen gas. So this process continues. So at the end, what will happen? So here the iron continuously loses its electrons. That means to say that its strength goes on decreasing due to the evolution of hydrogen gas. This is one type of reaction that takes place at cathode. The another one is another type of corrosion that is mainly due to the absorption of oxygen. This type of corrosion reaction takes place in the presence of atmospheric oxygen. In neutral and alkaline solutions, the concentration of hydrogen ion is very low. Thus, evolution of hydrogen gas is not favorable. That is 2H plus and 2 electron that gives H2. Hydrogen gas evolved reaction is not possible. So in such cases, what will happen? The reduction of oxygen to hydroxyl ion occurs. So oxygen in presence of water reacts with the electrons to produce hydroxyl ions. Let us take the same example, rusting of iron. At anode, what will happen? Iron will be undergoes oxidation to give Fe2 plus and 2 electrons. The electrons travel to cathode through metal surface and react with oxygen to produce hydroxyl ions. So O2 plus H2O plus electron that gives hydroxyl ions. We call this as a cathodic reaction. And Fe2 plus produced at anode travel to cathodic region through the moisture and reacts with OH minus ions to produce FeOH twice. This ferric hydroxide FeOH twice produced further undergoes oxidation in presence of water to give FeOH thrice or Fe2O33H2O, that is nothing but the rust. Right? It may be noted that although corrosion occurs at anode, the rust is formed near the cathode. Why it is so? This is because smaller Fe2 plus ions produced at anode diffuse rapidly towards cathode as compared to the diffusion of larger OH minus ions towards anode. This type of corrosion we call corrosion that is due to the absorption of oxygen. Basically, in electrochemical theory of corrosion, if you take the iron as an example, at anode, oxidation takes place, iron loses electrons, Fe2 plus and 2 electrons are formed, and these electrons that will move through metallic surface towards cathode and responsible for two types of corrosion. One is hydrogen evolution type corrosion, another one corrosion due to absorption of oxygen, right? So now, next we move on to, this is about the electrochemical theory of now the factors which is responsible for corrosion? There are two main factors for the corrosion of metals. One is nature of metals, another one is nature of corroding environment. If I say nature of metals, it includes number one, the position of the metal in electrochemical series. Number two, over voltage. Number three, relative areas of anodic and cathodic area. Number four, purity of metal. Number five, physical state of metal. Number six, nature of surface, film formed on the surface of metal, and solubility of corrosion products and volatility of the corrosion products. The second one is nature of corroding environment. It includes several physical conditions of the environment, such as temperature, humidity, pH, presence of pollutants like SO2, H2S, NOx, and suspended particles along with oxygen. These are the factors which causes corrosion. Then, what are the effects of corrosion? Number one, corrosion reduces the thickness of the metal, resulting in the loss of mechanical strength and failure of the structure. Second one, corrosion causes structural failure as it is hazardous, mainly in aircrafts. Number three, because of deterioration of appearance, the cost of machine is reduced. So because it loses luster due to corrosion, so there will be no shining. So certainly the cost of the machine is reduced. The efficiency of the machine is reduced due to corrosion. So due to corrosion, the structural properties, there will be a vary in the structural properties so that the efficiency of machine certainly reduced. Because of corrosion, pipes are blocked and pumps are difficult to operate. Because of corrosion, boilers are damaged. Boilers are damaged. We have studied already. Say, suppose if the hot water, if it is passed to the boilers, then there will be a formation of scales, sludges, and boiler corrosion because dissolved oxygen, carbon dioxide, and acids are present in the hot water, which ultimately results in the boiler corrosion. Buildings and other historic monuments are damaged due to the corrosion. So these are the effects of the corrosion. So far we have discussed what is corrosion, what are the causes for this corrosion, what are the main theories behind the theories which explains the corrosion. Number one, acid theory. Number one, dry. Number two, dry theory of corrosion, and most important one is electrochemical theory of corrosion. And also, what are the factors which causes corrosion, and what is the effect of corrosion. Thank you very much. In our next class, we will talk about types of electrochemical reactions and how to prevent and control corrosion. Thank you.